Hello all. Today we are going to discuss DES algorithm from Unit 2. So data encryption algorithm, that what we call the DES. Now DES algorithm is most widely used encryption algorithm in the world. Now as you know, in Unit 1 we are again discuss about encryption. Encryption is a technique where again the plain data which we using some algorithms we use to encrypt in a ciphertext, and that what we call the encrypted text, that is a ciphertext, and that again we require different algorithms for encryptions. So here one of the algorithm what we are going to discuss today is a DES algorithm, data encryption standard algorithm. Yeah. So here in this particular DES algorithm, over a list of decades, there has been an accelerating increase in accumulation and a communication of a digital data by government, industry, and other organizations in the private sector. The content of these communications and the stored data often have the significant value, or you can just sensitivity of that particular data, and this data can be again having can be again misused and misused by again theft or change in data, or again modification of that data which is again very sensitive for that business or business related data, and again it can be misuse of that confidential information about those people or other people who again given that data. So that what it does, that is again the data theft, you can say, and that is one of the thing, and the need of that protection for this particular data is very essential. And when we are talking about the the protection of data, and it is again recognized that the encryption is the only means of protecting data during the transmission, or again when we are protecting that particular content of data stored on a various mediums, and it's provide encryption of adequate strength to such data is very important. And for that it again most of the people prefer DES or data encryption standard to again encrypt that data. Basically when we are talking about the data encryption standard, it again it is a block cipher. Now block cipher is a plain text bit, and it used to how it operates, it's like in block cipher it again used to take a block of data, and then that again it used to generate that block of data or text, you can say, and that again used to generate into ciphertext. So there are two types basically, block cipher and stream cipher. A stream means again bit to bit it used to transfer, or it used to shift from plain data to again cipher data or encrypted data, that you can say. And again it is a type of FAS2 cipher. Now the FAS2 cipher is a structure, or the you can say the type of cipher where it again that structure is used for the encryption. Okay, and same structure which is used for when we are talking about the encryption, and the same structure when we are using for encryption and decryption, and there are different rounds are there in that particular encryption and decryption, and every round again using different key. So that what we call the FAS2 cipher. So that is the structure basically, and that comes under the FAS2 cipher. So DES comes under FAS2 cipher, and that again comes under the block cipher, means how it operates in block cipher mode. So it is take a block of data or plain text, and then it used to again convert block of data into the ciphertext. So that data encryption standard, when we are talking about the DES algorithm, again there are different steps we have to follow that algorithm which we are going to again discuss. But first, when we are talking about the DES, so what is the input and what is the output, that we are going to discuss first. So it used to take a plain text, which is again it is used to process, and it again is to convert into the encryption or a ciphertext, that is 64-bit block it is to take at every time. And there is a key, okay, and the key size is 56 bits. Yeah, and there are total number 16 number of rounds, and every number of round again required a key and different key which is required. So there are total 16 keys which we required for DES. So this is again general outline how the DES algorithm works. So here there are 16 rounds which are there. Round 1, round 2, round 3. There are total 16 rounds are there. We are taking input, a plain text input at the 64-bit, and again key we are going to take as a 64-bit. But again with the permutation, it again converted into the 56-bit key. So here what we require is a plain text, and for encryption we required key which is again 56-bit key. Okay, so using that again 56-bit key, what we are getting, and there's a permutation choice. Now permutation is there are now here when we are talking about input of 64-bit plain text. So that plain text is again arranged into 8 into 8 by matrix, and that comes as it again became a 64-bit plain text, and that every bit having some position, yeah, in matrix, and 8 into 8 matrix, and that position is changed. Okay, and that what is called the initial permutation. Okay, so when we are changing the bits position, so that is called the permutations. So here the 64-bit plain text what we have taken as an input, that again we are changing bit position, so that what is called the initial permutation. Same way again we are going to change the key key content again bits, and those bit position we are going to change, so that what is called the permutation choice 1. Okay, so here 64-bit is there, and again we are compressing that 64-bit into 56-bit, so that is a compression. Okay, so we are again again in next slides I am going to tell you how the compression and again expansion, again we require expansion over here, so how the compression and expansion is going to happen. Yeah. So here first we will see how the things are going. So first when we are initial permutation is going to happen, so we are changing bit positions. So there's a round 1. Okay, after changing bit positions, after 64-bit we are changing bit position, and again we are going for round 1. So in round 1 we required a key, so that key which is again 64-bit key, that again we are compressing into 56-bit key, okay, with the permitted choice, and then we are going to move that key, or we are again doing one operation, that is left circular shift. Okay, so we are shifting that key into left. Okay, so that is left circular key, and again next slides I am going to tell you in detail what is left circular in detail, but this is how the things, okay, the 56 bits are arranged in that manner, and that again can again moved at the left side, so bit by bit, so that is left circular shift. And then the left circular shift, when we are again the output is again the 56-bit. okay, after 56-bit what we are getting after left circular shift, so there is again permuted choice 2. okay, in permuted choice 2 the 56-bit became, okay, when we are giving this K1, okay, so that K1 became a 48-bit, means again we are compressing the bits. Okay, so how, so again there are again the matrix is there, and that matrix again 8 bits randomly we are going to take, and that we are going to eliminate. So that is again how we are going to eliminate those, or again how we are going to compress the thing. So here what we are having at the permitted choice 1, at the key side we are having the key 1, and then there is a second left circular shift. After that we are going to do permutation, so that's compression. So we are again eliminating 8 bits. Okay, and after eliminating 8 bits again at the K1 we are getting the 48-bit. okay, so that is given as a key input to round 1. okay, so that what we are going to give key to the round 1. So there are total number of 60 rounds. okay, 16 rounds are there. So every time, okay, what happened, the round 1, round 2, round 3, round 4, likewise total 16 rounds going to happen. Every time the key will be different, means what, the permitted choice is there, so 56 bits are there. So these 56 bits, so here first what happened, so first we are going to give left circular shift to that permitted choice, and then the again that is a we are going to implement permitted choice 2, so that key is going to compress and it will become a 48-bit, that is K1, and that is given to round 1. Same thing, again key goes down for the second round also, and again it it work for the, again it goes for the left circular shift. After implementing left circular shift, again there is a permitted choice, and that key which is again left circular shift which again implemented permitted choice 2, and it becomes a 48 bit. So K1 and K2 totally different. Yeah, likewise there will be K1, K2, K3, K4, K6, like K16. So there are total 16 keys, different keys which we are going to generate. Okay, and that we are going to give for every round. Okay, now every round there will be again this 64-bit plain text will be again there. So what is going to happen in round, that we are going to check in next slides. So here see, this is what is going to happen in the rounds. Okay, now here in this round what we are having, again we are giving different 16 keys in different 16 rounds. After that what we are getting is the 64-bit again output. Yeah, so after 16 rounds we are going to get 64-bit output, and that 64-bit again we are going to swap whatever we are getting, so that we are going to swap. Okay, 32-bit swap means first 32-bit we are swapping to their position with the next 31, and that next 31 we are going to swapping with the first position bits. So that is what the swapping. So this is what the 32-bit swap is going to happen. So we are changing position, and after that there is a final step is there. So that is inverse initial permutation. In inverse initial permutation, where whatever we did at the first, so that is initial permutation. Okay, the first step when we are going to take when we took the plain text, so that time we did one permutation, so that we are going to rearrange. Okay, rearranging the position what we had previous. Okay, so that what we are going to again rearranging the position of bits, so that what is called the inverse initial permutation. So that is what the last step, and after that we are going to get the 64-bit ciphertext. Okay, the 64-bit ciphertext what we are getting. So that ciphertext means what, the encrypted text. Okay, so how to see, this is these are the steps. Okay, 64-bit plain text we are taking, again initial permutation means we are changing the bits position, and after that there is a round 1. Okay, what we required around 1, so again 64-bit key which we are taking, okay, for encryption purpose. So that key is again 8 into 8 random bits which are there. Okay, so those bits again we are changing position, and we are compressing. Compressing means what, again here we are eliminating 8 bits. Okay, from 64-bit here we are eliminating, so we are taking only 56 bits. So again randomly 8 bits we are going to eliminate. After that we are implementing left circular shift, so it is again moving to left, and after that there is a permitted choice 2. In permitted choice 2 again it will eliminate 8 bits. Okay, and it will again give you the K1 output, that is for round 1. Likewise again there are different circular shifts, 16 circular shifts, there are 16 rounds, and we are going to get 16 keys. After that we are going to get in after 16 rounds what we are going to have is a 32-bit swap. So first 32-bit, the 32-bit are there, total the 64 bits what we are going to get in after the 16 rounds. So first 32-bit we are going to swap with the again second position, and the second position we are going to swap with the first position, and then whatever we are getting, okay, again 64-bit output what we are getting, so that we are again converting into the inverse initial position. Means there's a what we did at the first, that is initial permutation, that again we are going to implement. Okay, so means whatever we have changed the position of bits, that again we are going to rearrange and put into the the real position. Okay, so that what inverse initial permutation, and then we are going to get 64-bit ciphertext. Now this is the diagram of single round. Okay, there are total 16 number of rounds what we saw in last PPT slide, but here we are talking about the rounds. Now here every round there are total 16 number of rounds, so every round having this kind of operations is going to happen. So what are those operations? So here there are L and R, again the data which we are going to take as input. Okay, so as we saw, there is again 64-bit data which we are taken as input, and there's an initial permutation which is to happen, and then it comes to the round. When it comes to round, again it is divided into two parts, that is 32-bit left part, 32-bit right part. Okay, so there is a 8 into 8 matrix that is again divided into two parts, left part and right part, which is again equal part, which is again 32-bit. At the right part of that 32-bit, okay, from the plain text, which we are again permuted for, we are changed the position, and again we are getting this. So that 32-bit, whatever we are getting from right side, that we are going to give to the expansion or the permutation. Okay, so again this is the expansion part that again we can call as a permutation. In this permutation, what happened? So again 32-bit we are again expanding with the 48-bit. So how we are going to expand, that I am going to explain in some next slides. Okay, so you just remember over here, this is the 32-bit what we are getting, and this is how we are expanding. So those 32-bit in matrix form, that we are going to expand with the 48-bit. Okay, now here what we are getting is a 48-bit. Okay, now here at the key, okay, this is the key. Okay, now again there are two parts. As we seen in a previous slide, there is a 56-bit key which we are getting. Okay, so there are again two parts. First, right and left, you can say C or D. So here two parts are there, 28-bit, 28-bit. So what we are going to do, again every part which is first 28-bit, that we are going to again implement for the left shift. The right part again we are put into the left shift. Okay, and whatever we are going to get the permutation. Okay, so that is basically what we are going to get is a 56. Okay, when we are again merging two things. Okay, key, so that is again 56, but that again we are compressing and will make that particular key as a 48-bit key. Yeah, so that became a 48, that is ki. Okay, so that again is a 48-bit key we are compressing, that is a permuted choice 2. Using that again we are going to again it becomes a 48-bit key. And again there is a one input, that what we are talked about. There are two parts of input data, yeah, plain text, and that we are again expanding with a, so one part is 32-bit that we are expanding and we are getting 48-bit. So this 48-bit plus key, whatever you are getting, so that is again 48-bit, and that we are XORing. Okay, after XORing again we are going to get the output which is 48-bit. That again we are going to have the S box. Okay, S box is again one of the thing that again next slides we are going to check how X box is working. So using X box, okay, now here you just have to remember S box is a substitution box. Okay, and in that substitution box there are total the things are there are different tables in X box, and from that you just have to take those values. Okay, so here because of that again this is using Xbox, we are going to compress the data, means again we are going to cut some data, and what we are going to get is a 32-bit. After implementing Xbox, we are getting 32-bit. Now key is again implemented using XOR. Again we are getting Xbox. After implementing Xbox, we are compressing data, and again 32-bit what we are getting. We are talking about this in round. Okay, and after that 32-bit data what we are getting, we are again permutation, means again we are changing the position of that bits, and again that bit again we are XORing with the left bits. Okay, there are two parts of plain text. Okay, and that left part which is again we are again put over there, so that we are going to take, and again with the permutation of that right part we are going to XOR with the left part, and whatever we are getting is the right part which is 32-bit. Yeah, and again after right key, immediate whatever we are getting, okay, 30-bit, same thing which we are going to put as a left key. Yeah, so again this is for round 1. Okay, so this what you can check is the LI and RI, which is again we are going to get input for the round 2. Yeah, and this how it is going to happen. Okay, and here in key, where after there are 28-bit keys are there, and when we are going to left shift those key, after left shifting that keys again 28-bit C and D will be again generated, which can be used for the next round. Okay, so this is how this is for the round 1. Okay, again I'm going to explain. See here what we are going to take as an input is again input is a again 64-bit data which we used to have. Again in we just did the initial permutation. After initial permutation, there again we are going to divide this data into 32-bit left and right part. So we are taking right part, we are expanding that right part. After expansion of that right part, that 32-bit data became a 48-bit data. Here we are talking about the keys. there are 56-bit keys which we saw, and that key again we are going to divide into two parts, C and D. So here every part we are going to again implement left shift over there. After implementing left shift, that again we are going to again implement permutation, so that 56-bit data became a 48-bit data. That 48-bit data plus that expansion permutation 48-bit data we are XORing. After XORing, there is a X box. Using X box, again we are going to compress the data, that is a 32-bit data, and that 32-bit data we are again implementing permutation means again we are changing the bit position. After changing bit position, we are getting 32-bit data that we are XORing with the remaining left side data of plain text. And after XORing, we are getting the data which we are going to implement for the, or we are taking as an input for the next round, which is RI, and that is a right side of data. Yeah, and the immediate when we are taking right side data at the first, okay, and after that whatever we are getting, so same data which we are taking at the left side for the next round, okay, and same about the keys. Yeah, so this is how it works. Yeah, so this is how the rounds are working in DES. So see, this is the matrix which is given, okay, the upper matrix and lower matrix and all. So bits are again arranged in this position. Now this is total 64 bits. Okay, so when we are talking about the permutation is there. So what we are going to do is we are going to change the bit position. Means if there is a 1, 2, 3, 4, 5, 6, like there are some the row wise it is written in a particular sequence. So instead of that, what we are going to do, again we can last row we can again put at the first, or first into the last, or again randomly we can put all those things, okay, by implementing some logic. So this is how it that is what we call the permutation. Okay, so rearranging the bits. Okay, so this is what the 8 into 8 matrix, and here the bits are arranged. So when this is as an example, we can say this is the input for the bits, and when we are, if instead of 1 we are putting 20, or instead of 35 we are putting 40, and in position of 40, and 40 in position of 40 we are going to put 35 likewise. Okay, or otherwise we can say this last column we are going to put into the first, and first we are going to put into the last. Likewise, again there are different sequences we can again have, and this is what we call the permutation. At the end of the round, we discussed that there is a again the inverse permutation. Now the inverse permutation is before any rounds the plaintext bits are permuted using the initial permutation. So we are changing the bit positions, and hence the end of the 16th round the inverse permutation is applied, and because of that all the initial permutation, or the real thing or real positions are there, that we are going to again put over there. So that what is called the inverse. As we saw expansion function, okay, in expansion function 32-bit key which is going to be again we are adding 16-bit and it becomes again 48-bit and all. So there are different things. One of the logic for expansion is where again if this is the 32-bit, so what we are going to do, the next thing which we are going to again take as an input for that, means again if there are 32 bits, so 1, 2, 3, 4 are the bits, so next bit which is 5, so that we are going to take as a again the extra bit for that. Okay, likewise if there is a 5, 6, 7, 8, so 9th is the next bit, but that we are going to take over here as an extra bit. Likewise we are going to take extra bit for that, and again this in this particular way. Okay, so here see 1, 2, 3 is an example. Okay, so here any value can be there, okay, as a in that particular bit. Okay, and what we are going to do, so in this particular bit position, if at the 4th bit position and anything is there and we require to expand, okay, so from 32 to 48, so what are you going to do, whatever is resides at the 5th bit position, so that we are going to put on the again next to 4th, and then again we are going to add again the 4th. Now here the 4th is what, again before 5th there is a 4, okay. So that we are going to put over there. So likewise we are going to again extend the things, okay. So again bits, again any data will be there as a bit, and that again we are going to put over there, okay. So here these are the bits position basically, and the data how we are going to put over there and how we are going to expand, okay. This is what the expansion function, using that we can change the data, means 32-bit data we are going to change into the 48-bit data. See, when we are talking about the S box is again, there is a S block takes as an input 6-bit argument and output for the 4 bits. So how it moves from 6-bit to 8 bits. So basically what happened, S box having now these are the S1 as you seen in the particular slide. S1 is there. Now S1 is what? The S1 is one of the slide or one of the thing where again this is one of the table, and in this table you can check over here 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 are there, okay. There are 48 bits are there, okay. And what is going to happen, so there are again 8 S boxes are there, okay. In this particular way there are values are there, okay. 48 values are there, and in this way what is there, so there are 8 S boxes are there, okay. Total 8 S boxes are there, okay. And when we are talking about the S boxes, so those X boxes having, when we are taking 6-bit argument or bits are, so first and last bit which again act as a the column number, yeah, and the middle one which are the again remaining 4 bits which are again work as a row number, okay. So those bits, whatever column number and row number value what we are getting from that we are going to consider, and that again we are going to convert into the bits. So that became 4 bits. So whatever we are going to take 6 bits, so those 6 bits again I am repeating that those 6 bits are again the first bit and last bit which is act for the column number, and there are 4 bits which are remaining, that is again used for the row number, okay. And using that again it will give you these values, okay, from different S boxes. So again there are different S boxes are there, and those again can be used for different again rounds, and these again S boxes values can be used, okay, ways to discard the keys. Like here we have 64-bit data and that becomes 48. So here the first column which we are going to discard, so these are the bits which we have, and this we are going to discard, and because of that we are getting 48-bit data from the 64-bit data. So when we are talking about the compression, so that time what happened, so if there is a 56-bit or 64-bit, we are going to convert into 56-bit, or 56-bit we are going to convert into 48-bit. So what is going to happen, so again there are 8 bits or 16 bits, so again first column or the second column or first row, that we are going to cut down, or randomly we are going to take those values and that we are going to cut down in the next round. So that is again compression, and that we are going to convert 56 bits into the 48 bits. So again when we are talking about the DS description, the decrypt must be unwinded, and the steps which we are again followed for the encryption, that again we have to do for the decryption, because it's a FreeSL for the same steps which we require to decrypt the things as FreeSL for say, and we require to again encryption steps whatever we did, okay. Though there are 16 rounds are there, so same steps which we require to follow in inverse way to again decrypt the things to recover the. So again we can check, this is what the 64 data plaintext we are taking. Yes, initial permutation, as we have seen, initial permutation is again we are changing the 64-bit positions, so that is initial permutation. How that again we discuss. So there is a round 1, round 2, there are total 16 number of rounds. There is a 56-bit key, that again we are going to permit it choice given to that, and that again we are changing the position. After that we are implementing left circular shift. After left circular shift, the 56-bit key is again implemented. It is again implement the 56-bit key again goes for the permitted choice 2, and after permitted choice 2 it becomes 48-bit keys, means it is compressed, means again 8 bits are reduced from that, and that what we discuss how it is reduced. So likewise there are total 60 number of rounds. Every time the permitted choice are different because there is a left, every time the data is changing because of left circular shift, and there are total 16 different keys which are we are using, and there is a 32 bit. After that there is a 32 bit swap, so we are changing the first 32 bit into the next 32 bit, and the next which we are going to change the position for the first, and at the end we are having inverse initial permutation. Whatever we are did at the start, initial permutation, so that those again we are changing position, so those position again we are rearranging at the end of that particular step. So that is inverse initial permutation, where again we are again giving the original position for those bits, and again we are getting 64-bit ciphertext as output. And this is the round, okay, as we have seen. So 64-bit what we are getting as an input. So that input data, text data, there are two parts which we have, R1 left and right. So left one and right one, we are taking first right one, which is half part, which is 32-bit, that we are expanding. After expansion means again we are adding those bits, okay, from given data we can add those bits, so that 32-bit data can be again became a 48-bit data that we are going to XOR with the key. So key again we are having two parts, we are taking 56-bit key in round. That round again we are going to divide that key into two parts, 28-bit key. That again every key 28-bit key we are going to implement left shift to it. After left implementing left shift, we are going to have the permutation, that permutation choice which is again it compress the key from 56 to 48-bit. That 48-bit and the input of that one key which we are again expanding and became 48, that we are going to XOR. After XORing we are getting 48-bit, which is again we are going to put into the S box. As we have seen, there are 6 bits, what every 6 there are 6 bits are there, okay, and total how many bits? So there are total 8 parts are there, okay, so there are total 48 what we are getting in 8 box. So there are as I said, there are total 8 X box are there. Because of those 8 box, again the row and column number which we are taken from those 6 bits, and we are eliminating the 2 bits from those 6 bits, every 6 bits, so it becomes a 32-bit. Okay, so we are eliminating those bits and we are getting 32 bits. After getting 32 bits, we are again rearranging the position of those bits, so that is a permutation. We are just rearranging, we are not compressing or again we are not expanding, so we are just rearranging. After rearranging position, there is again it gives the 32-bit output, and that 32-bit output we are again XORing with the left side of that particular key, okay, for the text what we are getting for encryption. So there is a one left side which is left behind, so that we are going to take and we are XORing with this again 32-bit, and again after XORing whatever we are getting as output which is 32-bit, that is we are using for the next round right side text, yeah, and whatever right side at the start we are taken, so same thing as it is we are going to take at the left side for the next round. Yeah, so how it is going to work in a single round? Okay, there are total 16 rounds. Every round used to happen in this way, okay, and every round having this kind of L1, R1, C1, D1, okay, and Li, Ry as the output, and Ci and Di as the output, okay, and Li, Ri, Ci and Di as the input. Yeah, fine. -1, -1. Okay, so likewise it is going to move in like 16 rounds. Yeah. Okay, so this is how the DS works. Thank you.